Yes, hello guys, welcome on your PDF platform. I hope your interview preparation is going fine. So guys, in the today's session, we are going to discuss very important interview questions for oil and gas company like ONGC, okay, IOCL and BPCL, these kind of industries like HPCL also. You know, they can ask you, what do you think, the crude oil is a kind of Newtonian fluid or non-Newtonian fluid? Or they can ask you to draw some kind of shear stress versus rate of shear strain diagram for crude oil. Or they can frame that question something like that. What do you think, like if you will change the speed of a pump, okay, from some like suppose 1000 rpm speed of the pump from 1000 rpm to 1500 rpm, what will be the change in viscosity of the crude oil? Okay, so there are many ways he can ask you, the interviewer can ask you this particular question. Okay, so guys, as you know, the behavior of crude oil is very complex. If you will talk about the rheological behavior of crude oil, it is very complex. But how to define that question? So what you need to say, sir, if you will check the rheological behavior of crude oil, so light crude oil at normal operating conditions, they are considered as Newtonian fluid. But if you will take very heavy crude oil at very low temperature, you know guys, the viscosity of the fluid is very sensitive to temperature. There are other properties also which depends on the temperature, like density, thermal conductivity. For the fluids, you know, for liquid, the viscosity generally decreases with the increase in temperature. For most of the fluids, for most of the liquids, viscosity decreases with the increase in temperature. And for gases, viscosity means the resistance between the fluid layer that increases with the increase in the temperature of the gases, okay, in general. Okay, so viscosity for fluids is very sensitive to the temperature. So when you are defining the behavior of a particular fluid, you need to define the conditions also, like the crude oil which you are having, it is at what conditions. So without conditions, although it is very difficult, it is very complex to define the rheological behavior of a crude oil. But under normal operating conditions, at what you can say, a light crude oil, that can be treated as a Newtonian fluid. And if you are able to answer this, then they can ask you, Acha, can you draw the shear stress versus shear strain diagram? Then easily you will be able to draw, because for Newtonian fluid, if you will take here the shear stress, here shear strain, so you will have a straight line. Why? Because for Newtonian fluid, the viscosity is not going to change with the rate of deformation. Shear stress is directly proportional to strain. So viscosity is what, guys, in this diagram, shear stress versus shear strain diagram, this slope of the line on shear stress versus shear strain diagram, that slope is nothing but viscosity. You know guys, if this slope is 0, the fluid will behave as an ideal fluid. The fluid which is having 0 viscosity, so 0 shear stress is required to flow. The stress will be 0 because viscosity is 0 for ideal fluid. And if viscosity, if this slope is infinite, something like this, so then this line belongs to what? Ideal solid. So this line belongs to orange color, this line, vertical line, belongs to ideal solid, this line belongs to ideal fluid, and in between you will have different type of fluids, real fluids. Okay. So Newtonian fluids are the fluids which obeys Newton's law of viscosity, which is nothing but shear stress is directly proportional to rate of shear strain, and mathematically this rate of shear strain is equal to the velocity gradient du by dy. So tau equal to mu du by dy. So this is the mathematical equation that we can write for light crude oil at normal operating range. But if you are having crude oil at very low temperature, you know, lubricants, if you are having at very low temperature, then their viscosity changes, their behavior, their rheological behavior will be very complex. In that case, we will not be able to answer ki you are going to have a, you know, Newtonian behavior or non-Newtonian behavior. In most of the cases at very low temperature, heavy crude oil, you are not going to have a Newtonian behavior, you will have a non-Newtonian fluids. Okay, but what type of non-Newtonian fluids, that will be further, you know, more complex. Different researchers, they carry out their studies. Okay, because in the crude oil there can be different substances mixed. Okay, it's a very complex mixture. So the properties, the behavior depends on so many parameters. Okay, so the study becomes more complex. So that analysis, the comment will not be that much easy to say ki, yes, the behavior will be something like the dilatant or pseudoplastic. I think you got the point. But how to define these type of question? Because if they are asking you this type of question, means they also know, they just want to check your understanding related to what you think about Newtonian fluid and what you feel like if a particular fluid is behaving as a Newtonian fluid, what it means. So if viscosity is constant, means if you are changing the speed of a pump with the rate of deformation, the viscosity is not going to change for the Newtonian fluids. But if you are having a kind of fluid which is not a Newtonian fluid, like non-Newtonian fluids like dilatant or pseudoplastic, then viscosity is going to change with the rate of deformation. You know guys, for dilatant fluids, They are also known as shear thickening fluids. With the rate of deformation, the viscosity is going to increase. So if you are changing the speed, then there are chances with the rate of deformation, their viscosity will increase. So they will become thick. Okay, there are some fluids for which with the rate of deformation, okay, if you are changing the speed of a pump, means if you are changing the deformation, then their viscosity will decrease. Those are known as pseudoplastic fluid. So there are some fluids, pseudoplastic, dilatant, but for Newtonian fluids, the viscosity is independent. What? It is going to be constant. It is not going to change with the rate of deformation. But there are some fluid whose viscosity changes with the rate of deformation. It can increase, it can decrease. We are going to discuss some basic about those fluids also. Okay, so I hope you got the idea. On what conditions we can say crude oil is a kind of Newtonian fluids. Okay, as also you need to say, sir, viscosity is a property which is very highly sensitive to the condition of a particular fluid. Condition is at what temperature, at what pressure you are having. On pressure, the dependency is very low, but on temperature, the dependency of viscosity is very high. Even with a very small change in temperature, viscosity changes will be huge. Viscosity is very, very sensitive to the temperature. Okay, so that's why the temperature is required to be defined if you want to define the behavior of a particular fluid. So I hope this is clear what you understand by Newtonian fluid and how to draw the shear stress versus shear strain diagram for a Newtonian fluid. What are the example, guys? What are the example for Newtonian fluids? Water, air, oil, petrol, diesel, they are considered as Newtonian fluids. Okay, so their viscosities are not going to change with the rate of deformation. Okay, and generally we'll write their mathematical equation something like this: tau equal to mu, where mu is the dynamic viscosity, tau is the shear stress, and this du by dy is nothing but velocity gradient, which is equal to, mathematically equal to, rate of shear strain d theta by dt. But guys, how to write this equation for non-Newtonian fluids? So for non-Newtonian fluids, guys, we write this mathematical equation which is also known as power law model. So that can be another question, how we define the mathematical behavior, like how we write the mathematical equation for a non-Newtonian fluids. So for non-Newtonian fluid, we write equation something like this: tau equal to A into du by dy ki power n plus b, where this a and b, a and b, these are different coefficients. A is actually kind of coefficient which defines the consistency. It's a kind of parameter which defines the consistency of a fluid. Okay, this is another index which defines the flow behavior. Okay, you need not to know like on what parameter we define. This can be greater than 1, equal to 1. If it is equal to 1, okay, if this is equal to 1, then the fluid will behave as a what? Newtonian fluid. If b is equal to 0, n equal to 1, this equation will become just equal to the Newton's law of viscosity. You got the point, guys? So n can be greater than 1, it can be less than 1 also. Okay, so this is a kind of index which tells us about the behavior of a fluid. It is a particular index which tells us, this is a parameter which tells us about the consistency of the fluid. This b is a constant, kind of constant, which tells us about the yield stress. Some fluid, guys, there are some fluid which require some kind of initial stress to begin the flow, like toothpaste. Like toothpaste, if you are applying some kind of stress, the flow is not going to begin. But some minimum stress is required to begin the flow. That is known as yield strength tau O. So tau means this minimum stress is required to begin the flow. After that stress requirement, like if you are providing that stress, then the flow will be something like Newtonian fluid. So you are going to have a linear line, but some kind of initial stress is required. So that's why these type of fluids are known as a Bingham plastic fluid. Okay, so there are some fluid which are known as dilatant, which are also known as shear thickening fluid. And as you can check, guys, here for dilatant, the slope is continuously increasing. What is slope? The slope is viscosity. The slope of a curve on tau versus shear strain diagram, that is nothing but viscosity. So as you can check here, the slope is very less, the slope is increasing means viscosity is increasing. Viscosity increasing means they are known as shear thickening fluid. इनको हम क्या बोलेंगे बच्चों? Shear thickening. For pseudoplastic, the slope is decreasing. It means the viscosity is decreasing. That's why they are known as shear thinning fluid. Okay, what are the example of pseudoplastic, guys? Blood, milk, colloidal solution. Those are the example of pseudoplastic fluid. What are the example of dilatant, guys? Dilatant का क्या example दे सकते हो? You know about sand in water, the corn flour solution, sand in water. Those are the example of dilatant fluid. I have already given you the example of what? This Newtonian fluid. Ketchup is also a kind of pseudoplastic. Ketchup भी क्या करेगी आपको? Like some force is required, and initially the stress, the viscosity will be very high, but with the rate of deformation, if you will increase the deformation, then the viscosity will decrease. Okay, it will be easily able to flow. Toothpaste is a kind of what? Bingham plastic fluid. There are some fluids, guys, for which the Viscosity is time dependent. Like if you are changing the stress over a time range, so viscosity can increase or viscosity can decrease. So those fluids are known as thixotropic and rheopactic. For thixotropic fluid, they are like over a time duration, if you are applying some kind of shear stress, the viscosity is going to decrease. Those are known as thixotropic. Like honey में अगर आप कोई stress applied कर रहे हो, some stress if you are applying, like suppose with some kind of pedal wheel arrangement, suppose if you are steering the honey, so with the time passes, stress is same, you are not increasing the shear stress, but with the time passes, with that same stress, the viscosity is going to decrease. So honey is a kind of thixotropic fluid, so viscosity is going to decrease with time dependent shear stress. Similarly, for some fluid, the viscosity can increase also. Those are known as rheopactic fluid, like lubricants, gypsum, printering. For these kind of fluids, the viscosity is going to increase with the time dependent shear stress. Okay, so I hope you got the point. What are non-Newtonian fluid, what are Newtonian fluid? Here I am trying to just only briefly discuss with you, because our main question was like, what you feel the crude oil is a kind of Newtonian or non-Newtonian fluid, and I think the first three questions you will be easily able to answer. What is the effect of the speed changes? What is the effect? How to write the shear stress versus shear strain diagram? Okay, how to draw that shear stress versus shear strain diagram for crude oil, light crude oil, and you know what, that for those kind of crude oil, Newtonian behavior you can analyze, and how to write the mathematical equation for those kind of Newtonian fluids. Okay, so these are the different example, guys, and in this equation, like you need to know what is this power law model, which is also known as Ostwald-de model. Okay, so for Newtonian fluids we write their mathematical equation using the Newton's law of viscosity, tau equal to mu du by dy, but for non-Newtonian fluids we use the equation which is also known as power law model or Ostwald-de model, which is given by tau equal to a du by dy ki power n plus b. Okay, this b may be 0, it may be non-zero, or this n can be greater than equal, greater than 0, or it may be less than 1 also. Sorry, it may be greater than 1 or less than 1 also. Okay, so these are the different fluids, guys. I hope you got the idea about different fluids. Here I am briefly discussing with you, so further you can explore. I hope this question you will be easily able to answer. The crude oil is a kind of Newtonian fluid or a kind of non-Newtonian fluid, and easily you will be able to answer these three questions. Okay, so please revise, keep preparing. Again we will meet and we will discuss some more interview questions for your interview profession. Thank you very much, keep preparing and have a nice day.